All right, what's going on, folks? Can you hear my voice? Can you see my face? Can you read this? Wait, you can't see my face? Can I make it bigger? Did that work? All right, good, okay. Let's get this party started. We're starting up on chapter 4, and I feel like it's going to be this one's going to be pretty straightforward. Let me see if I can do this. Hold on one second. Let me close this door, close this light, maybe the light will work. All right, here we go. Can you see that better? Is that better? It's hard for me to see your typing. Let me adjust the font on your side. Sorry. Just getting everything all set up. Let me just adjust the font. I'm gonna do my best to see it, but I've got the camera way over there, and I'm standing way over here. So hopefully this class will work for us today. All right. Anyway, check this out. I'm going to graph something. Let's graph it. I'm going to graph. I want you to get out a piece of paper. I want you to draw this graph. Okay, let's see. Crosses here at -1. It crosses here at +1. And it crosses here at +2. And the graph kind of looks like this. And it comes all the way up over here at 6. Here, 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 here. It kind of looks like that. All right. We good? Can you see? Okay, awesome. Okay. So it's 1, 6, 1, and 2. Okay, so check this out. What are the x-intercepts? -1, 1, and 2. What is the y-intercept? I'm just gathering information here. What we're going to do is we're going to try to figure out what this f of x is equal to, f of x. But in order to do that, we're going to gather some information. So what is our y-intercept is at 0, 6. So our y-intercept is at 0, 6. And technically, yes, I should have put down coordinates for each of these. This would be -1, 0, and also 1, 0, and also 2, 0. Because for the x-intercepts, the y value is 0. Vice versa, for the y-intercept, the x value is 0. Are we cool with that? Would it be freaky to you if I just took this information right here and I just straight up wrote down that f of x is equal to x plus 1, x minus 1, and x minus 2. All right, that might not be the right answer, but would it be all right if I said that it looks something like what Sophia's suggesting? And I wouldn't have to say x1, x2, x3 because these are variables. But is that all right with you? The reason why I'm able to say that is because, look, if we take something, okay, Ethan doesn't like it. Sophia says, okay, Sophia, we'll get to the a value in just a second, but let me explain to Ethan what's going on. Ethan, what I'm suggesting here is, I'm suggesting this is the right form of the answer. It's not necessarily the right answer, but it's the right looking answer because, based on the idea that my x-intercepts is at -1, +1, and 2. In quadratics, we just kind of went straight from here to there immediately. And so I'm kind of doing it backwards. If you really think about it, if I plug in -1 into this equation, then what is -1 plus 1? That's 0, right? And then what is negative 1 minus 1? Well, that's negative 2. And then what is negative 1 minus 2? Well, that's negative 3. But it doesn't matter what these two are, because if the first one is 0 and I'm multiplying them all together, then that's going to equal to 0, and hence that's why my x-intercept is at negative 1. Do you understand this equation now? This equation kind of takes into account each of these things being 0 based off of what I have for my x-intercepts. We cool? All right, so are you happy now? Have I sung and danced enough for you? All right, good, good, good. So here's the thing that we've kind of realized, though. I got a question real quick. Do you like it better with the lights off or the lights on? Because this is the lights off right now. Either? Okay, all right. It's up to you. Let's try it on. There's a glare. Okay, let's turn it on. Let me see what happens to the glare. I don't know if it makes the glare worse or what. That's better? Okay, all right, fine. Okay, way better. All right, fine. So we're cool with this, right? We like this? Okay. All right, then Sophia is suggesting. All right, here's what I'm suggesting. This is the correct form, but there might be something that's a little bit funky, and I think Sophia figured it out. But before Sophia figures it out, let's kind of figure out what is the y-intercept of this graph, of this equation. Well, for the y-intercept, you plug in x equals 0, so really you have 1 times negative 1 times negative 2, which gives you positive 2. No, positive 2, because you have a 1 over here, but a negative 1 and a negative 2. Negative 1 times negative 2 is positive 2. We cool? The problem is we need to get this thing up to be 6. You see what I mean? So how can I scale this thing up to be 6 without... there we go, Sophia. So what Sophia's suggesting is she's saying, well, what happens if we multiply 2 times 3? What would happen? It would give me 6. So that's the right y-intercept. So what I'm suggesting is that if you multiply a 3 out in front, what that's going to do is that's going to give you the correct y-intercept, but it's not going to change the x-intercepts. Your x-intercepts are still going to hit at negative 1, positive 1, and positive 2. But this time, this graph looks a little bit more correct. See, at first we had a graph that kind of looked like this. It was like the wimpy version of the graph that we actually were supposed to have. And so what we did was we put a 3 out in front, and what that 3 did is it kept those x-intercepts the same. But what it did is it's the gummy bear effect, right? You pull this thing down, and you pull this thing up, and then this comes down, and that comes up, and so it stretches the thing out, but still keeping the same x-intercepts. Does that make sense to you? Literally, that's pretty much this entire chapter. I think I have like 4 more example problems to go through, but that's it. If you understood this, then you get polynomial 4. Let's try another one. Oh, I'm sorry. I think that this is done. We're done. That's the whole math part. But I think that in asking you to give it to me in an answer, the hard part is I can't tell the computer for you to plug this in. You see what I mean? So what I might ask you to do, and I think I do this in the homework, I can't remember it exactly or not, but let's FOIL out this entire thing. You're going to get good at foiling today. So let me see. 3 times x plus 1 times x squared minus 3x plus 2. Okay, all I did was I FOILed those last 2 things, first, outer, inner, last. You see what I did? Is everyone cool with that? Wait, I don't understand that response. Is that a frustrated arg, or is that a lag? Oh, okay. Do you understand what I did here? I just wrote down this line, but instead I foiled out the last two parts. Okay, good, good. And then what I'm going to do is I'm going to multiply in this x and also multiply in that 1. Let's see, this would be x cubed minus 3x squared plus 2x plus x squared minus 3x plus 2. All I did was I multiplied this whole thing by x, and then I put a big plus sign in between there, and then I multiplied this whole thing by 1. Are we good here? Nothing crazy, nothing new, nothing hard. Okay, combining like terms, this negative 3x squared gets killed by that positive x squared, and so I just have x cubed minus 2x squared minus x plus 2. And if it's all right with you, I'm going to go through and I did a whole lot of foiling in homework 3.4. It was a pain. Okay, yeah. That's what we're doing. We're just doing foiling. Yeah, it was a pain, but it's not hard. Okay. I'm going to go ahead and multiply every single term by 3 because of that 3 outside over here. Is that all right with you? So this becomes 3 and 6 and negative 3 and positive 6. Anyone unclear as to how I got 3, 6, 3, and negative, or 3, negative 6, negative 3, and positive 6? Okay, yeah. I think that when I ask you to give me the answer in the homework, I'm going to ask for the A, B, C, and D. And it's one of those things where you just choose the numbers. So the answer to this is A is equal to 3, B is equal to negative 6, C is equal to negative 3, and D is equal to 6. Because we have a cubic function, obviously, because it's x cubed, and the coefficients would be A, B, C, and D. We cool? I think if it were a function that has to the 4th power, I would ask you what is A, B, C, D, and E, and so on and so forth. But I mean, nothing real hard, just this is really all the math. And then over here is just foiling. All this stuff over here. Ethan, I think that do you want me to go over foiling slowly with you? Do you want me to show you exactly all the steps I took? I might have done some in my head. Feel free. Okay, all right, fine. I'll do that because maybe it might be helpful to other people. And I'm not singling you out. I'm not trying to make you, or I just want to help, okay? All right, so let me just redo this problem 3 times. Actually, would it be right with you if I do another problem, but I do every single step? That way we can see something different. All right. So I'm going to erase. I apologize, but don't worry, I'm recording it if you're not done writing it down. All right, let's see. Let's try this function right here. Okay, all right, here we go. It looks something like this. It crosses here at negative 2. It crosses here at negative 1. And it goes all the way up to here at 4. 1, 2, 3, 4. Oh, you guys can't see that. Sorry. All right, let's see. Draw the graph for me and positive 1. So here, 1, 2, 3, 4, and here. It kind of looks like this. Are we cool with that? All right. Here's negative 2, here's negative 1, and here's positive 4. What are your thoughts? Are we looking at a cubic function, a quadratic, a linear function? Cubic. And you guys got cubic because why? I'm just curious to know. Because both ends are in the opposite direction. I like that. So why is it not yeah, because it has 2 bends. I like that a lot. So it's not a linear function because a linear function doesn't have any bends. It has two bends. I like that idea. So I would say yes, the easiest function this could be is at easiest a cubic function, because it can't be a quadratic. Quadratics kind of look like that, and this one goes up and down. Are we cool? Now technically, it could be a to the 5th power or to the 7th power. Maybe there could be like an extra bump in here. You know what I mean? It doesn't look like it, but looks can be deceiving, and that's why I said the easiest thing it could be would be the cubic function. It could be to the 5th, it could be to the 7th. To be honest with you, I don't think it is. I really think it is a cubic function, but it could be, you know. All right, anyway, I'm going to jump straight into this part, Ethan, and tell me if you're freaking out about it, but I'm going to say that f of x probably looks something like a times x plus 2, x plus 1, x minus 1. Did I lose anybody there? Wait 1 second. I got to tell the computer to stop. I'm gonna need to switch the settings. Tell the computer to stop going into screensaver mode, or turn display off. Never. Okay. All right. There we go. Okay. What exactly is a? Well, that's a good question. How's about this? This is actually the same as y, the f of x, right? So my y-intercept is 0, 4. Or what I'm saying is, if x is 0, then y is equal to 4. Does that make sense? So I'll just plug in that number. So I have 4 is equal to whatever a is, I don't know, but 0 plus 2, 0 plus 1, 0 minus 1. Okay, this is pretty easy because this is really just 2 times 1 times negative 1. So this is 4 is equal to a times negative 2. Oh, that's pretty simple to solve. So I have a is equal to divide by negative 2. And so I have a is equal to negative 2. Not that hard. So we figured out what a is. Are we cool with that? I'm going to erase in just a second. All right. I'm going to erase here, and I'm going to replace this a with a negative 2. Because I figured out what that's supposed to be. Okay, I like this because this is a cubic function. This has a negative a coefficient, so it means the regular cubic function looks kind of like that. And so a negative version would look kind of like that, which is exactly what mine looks like. Are we happy with this? All right. So now we're done. We're all done. We figured out what f of x is equal to. We're good. The problem is, I want you to put this in, see, this would be like a factored form. But now I need you to do it in standard form. Okay, well, Ethan, here we go. You ready? FOIL is first, outer, inner, last. All right? So if it's all right with you, I'm going to FOIL these two guys together. I could FOIL these two guys together, or even these two together. It doesn't matter which order I multiply it in, as long as I just, start collapsing things down. So foiling, first would be x times x, so I have x squared. The outers would be negative x, because x times negative 1 is negative x. Inners would be plus x, and last would be negative 1, because 1 times negative 1 is negative 1. Did I lose you there? All right, good. I'm going to combine like terms at this point. The negative x and the positive x cancel itself out, so I really have x squared minus 1. So really, instead of writing this, I could have just wrote x squared minus 1. I still have my x plus 2. I still have my 2 up. We cool? Now, this one is a little bit different from the previous one, and maybe I should have done the previous one because that part might have been confusing for you. This is actually a little easier. If it's all right with you, actually, I'm gonna do this one, and then I'm gonna go back to that previous one and see if I can recreate it, if that's all right. All right. So this one's pretty easy. You FOIL it again because it's a binomial times a binomial, so you have first, outer, inner, last. So it's really just this x term is meeting everyone inside of here, okay? And then this second term, the 2, is meeting everyone, actually maybe I should do it on top, is meeting everyone inside of here. So this x gets multiplied by this and that. And then the 2 gets multiplied by that and that. We cool? That's essentially the idea of foiling. I think that the confusing part was on the previous problem, I don't know. The previous problem, there were 3 numbers in the last part. Well, that's pretty easy. It would just be the x gets multiplied by this, this, and this. And then you put a plus sign over here, because that's the plus sign. And then the 2 gets multiplied by this, this, and this. Do you see what I'm getting at? Yeah, it's a little hard to keep track of things, and that's why you got to be careful. But essentially, that's what foiling is. We're just making sure that everything in the first... I think, remember I taught to you guys, and I taught it to you as like people in dorms, and then these 2 people are meeting these 2 people for the first time? Yeah, oh yeah. Well, imagine if you had 2 people meeting 3 people. Well, this first person has to meet all 3 people, and then the second person has to meet all 3 people. That's essentially what it is. You'll end up with really long lines of math, but it's not hard. It's just multiplying and adding, really. Anyway, foiling this out, I end up getting, I'm going to have this x meet everyone in here. So I have x times x squared, which is x cubed. I have x times negative x, or negative 1, so I have negative x. And then I'm going to have the 2 meet everyone in there. So I have 2x squared, and I have a negative 2. Did I lose anybody here? Oh, I'm sorry. There's one more piece. There. I still have that 2 out in front. It's that same 2 out there. I'm just foiling this part over here, but that 2 is still there. Are we cool with that? Why shouldn't the 2 be negative? You're talking about this one? No, that's A. Oh, you're right. I'm sorry. You're absolutely right. It should be negative. I just forgot to write it. Which is thank you so much for finding that mistake. It would have screwed up my entire answer. I guess I got lost with it being close to the equal sign. Don't do that. All right. I'm just going to multiply. This is kind of like foiling again. You just want the negative 2 to meet everybody inside, and there's 4 different people that are inside. So it's really just one person meeting everybody inside, as opposed to like 2 or 3 or whatever. It's just one person. So you're really just distributing at that point. So it's negative 2x cubed plus 2x minus 4x squared plus 4. And if it's all right with you, I always like writing things from biggest order to smallest, so I would probably write negative 2x cubed minus 4x squared plus 2x plus 4. I just switched these 2 around, which is fine, just because I have x cubed, x squared, x, and then no x. Yeah, actually, it's easy immediately to identify A, B, and C. It's negative 2, negative 4, 2, and 4. So I think in your answer, if I ask what is A, B, and C, and D, you would put -2, -4, 2, and 4. And that's how you would do that. All right, so that one I did foiling real slow. And did it freak anybody out? Are we good? Thumbs up, thumbs down, thumbs I don't know. Okay, cool. I wanted to get to a harder one. Actually, I really wanted to get to polynomial 5. If you feel like we got this, then is it right if I move on? I want to at least introduce polynomial 5. I won't finish it, I promise. Sorry, I'm watching Poly 4 later today. Okay, all right, here, let me erase this and I'll move on to Poly 5. Because essentially, that's all of Poly 4. It's all about figuring out what that A is. It's not even really about figuring out what that A is. It's about knowing the factors and then figuring out what the A is. And then the extra step that Mr. Dalday is doing, because he's a jerk and he wants you to be good at foiling in your head, is he asks you to foil out the whole darn thing. And that's not necessarily that's not necessary. It's just that's the jerk move that I'm doing. Hey, I don't care if you guys hate me. I like you. But anyway, all right. Here's the thing that I want to do with Poly 5. Okay. Long division. Now, remember when you guys were like 5 years old and you guys learned long division, you guys like, oh, I hate long division, right? You hate long division? Yeah. Memories, horrible memories. I hated long division. Okay, all right, fine. You hate long division. But look, you guys are, what, like 15 now? 16? 15, all right. So you're 15 years old. You're 3 times as old as you were when you learned long division. Is it all right if we revisit long division? And don't worry, I'll start off easy. What I really want to do is understand the steps. In fact, this is kind of the point of learning long division. Because there's easier ways to do division than long division. I remember I'm teaching my son long division now, or I was teaching him earlier this year, and my wife asked me, she goes, why the heck is he learning long division when he has a calculator? Plus, there's easier ways to do this. And I said, well, there's this topic in Algebra 2 that you're going to need to understand the steps behind long division. So long division is easier than this topic in Algebra 2, but in order to get to that, I'm going to need to teach them algebra, long division. And so my wife was like, oh, I get it. And I was like, yeah, a lot of teachers hate teaching long division because they don't understand that, that what they don't have all the math background to see what's coming up. And so congratulations, folks. You guys are at that special topic that, you now have to know long division in order to understand. So let me reintroduce long division to you. And it's really, long division is not that bad, especially since you're like 3 times as old as when you first learned it. What we ask ourselves is, how many times can 5 go into 8? 1 time, okay. So what you're telling me is if I multiplied 1 times 5, I would get a number that's not bigger than 8, but at least it can go into it. It's maybe the most amount of times it could go into it, but not bigger than. Okay, all right. And then what do? We multiply this 1 times the 5, and we end up getting 5, really. Right? And then we subtract. But I'm not a big fan of subtracting. I'm never a big fan of subtracting. So if it's all right with you, I'm going to add -5. Are we cool with that? Okay, all right. Which is 3. And then we drop this sucker down. So 5 minus, oh no, put a 7 there. There we go, okay, good. All right, how many times can 5 go into 7? Or 37, I'm sorry, 37. 7 times, because, all right, fine. So that's the most amount of times it can go into, but not over. All right, so 35, because 7 times 5 is 35. Instead of subtracting, I'm going to add a negative, which you guys are thinking, why the hell is he doing it? I just like adding negatives. This would be 2. We cool with that? And then you drop down to 5, and you end up getting, well, how many times can 5 go into 25? 5. And you get 25 here, and you subtract them. Well, add a negative, and you get 0, and everyone's happy. We cool? All right. Recap on the steps for long division. How many times can 5 go into each of these numbers? Then you put that number up there. Then you multiply that by whatever you have here. You put that over here, and then you subtract them. Rinse, wash, and repeat that same process until you get to the bottom. Are we cool with that? All right. I'm going to show you guys something that will freak you out. I shouldn't say that because I don't want you to freak out. Can you guys see that? I'm sorry, this is a 3x squared. Let me move this real quick. And I'm going to put a x minus 2. This was on the PSAT practice thing. Oh, good. That means you guys know it's worth learning. All right, let's try it. How much time do I got? Can't tell. All right, let's try it. So here's what I'm going to do. I'm going to ask you, we're kind of only looking at this first number right here, okay? And we'll go through each of these things, just like what we did with long division. We did the 8 first, then the 7, and then the 5. Okay, so the first question I have is, what do you have to multiply x cubed by? No. What do you have to multiply x by in order to make it x cubed? X squared. Okay, good. I like that. Because if I were to multiply x squared times x, I would get x cubed. We're happy with that. Does that make sense? Okay. So now what I have to do is that whole process of multiplying this number times whatever's out here. Just like what I did with multiplying the 1 times the 5, or the 7 times the 5 and getting the 35, or the 5 times the 5 and getting the 25. I got to multiply the x squared times whatever that is. We cool? So this would be x cubed minus 2x squared. Did I lose anybody? I get it, or yes, I'm solid. That makes sense. I don't get it. Okay. Ethan, all I did was I took this x squared and I multiplied him by x minus 2. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. You just foiled that thing in there. We cool? You don't get the x cubed minus 2x squared. You don't get this thing right here. I just explained to you where that came from. Okay, Bradley, you just got logged off and you logged back in. Does this freak you out? Yes, okay, all right. Do you understand how the x squared came up there? Okay. Okay, all right, okay, wait. Yeah, Ethan, no, I'm going to answer your question. Let me just go back for Bradley. He got logged out. It's not his fault. Bradley, what I asked myself is, what do I have to multiply x by to make it x cubed? X squared, right? Because x squared times x would give me x cubed. Are we cool with that? Now what I asked myself is I said, okay, well now I go through this process, right? So I have a 1 up here, I'll multiply it by 5, and I put that down here. We cool with that? I take the number on top, I multiply it by whatever it's being divided by, and I put it underneath. Yes, you're good? Okay, and then for Ethan, if I have x squared times x minus 2, because this is me taking that thing on top and multiplying it by that number in front, then really I have x cubed minus 2x squared. Ethan, we good? You get it now? Good, good. That's a good thing. Okay, so if it's all right with you, I'm going to write this as x cubed minus 2x squared. It's not hard. It takes organization. It takes being careful. Not hard. Okay, I'm going to subtract this thing, but like I said, I like, instead of subtracting, I like adding a negative. And when I add a negative, when I have a negative x cubed minus 2x squared, oh wait, sorry. When I have a negative, what would happen? Oh yeah. When I have a negative x cubed minus 2x squared, I'm going to change the sign of each thing in there. So it's negative x cubed plus 2x squared. Do you understand? Essentially, what I'm saying here is I'm going to subtract this, so I have to change the sign of everything in there. So this becomes a negative, and that becomes a positive. Are we cool with that? When I change the sign of everything in there, now I can just straight up add them. 3x squared plus 2x squared is 5x squared, and then 3x cubed minus 2, or x cubed, not 3x cubed, but x cubed minus x cubed is 0. Are we cool? Yes, I'm good. No, I hate this. All right, good. Let's play the same game. How many times, or what do I have to multiply x by, which is that number I double underlined, in order to get 5x squared? Oh, I'm sorry. I forgot to drop this thing down. So I'm going to negative 13x. But you don't have to really worry about that just yet. What I'm asking is, okay, Sophia is saying you need to multiply x by 5x, and you would get 5x squared, right? X times 5x is 5x squared. Are we cool? So I would suggest putting a 5x up on top. We're good? So now what I'm going to do is I'm going to multiply everything over here by 5x. Just the 5x. Everything over here by 5x. Okay, so I end up getting 5x squared minus 10x. Lose anybody? Good? Bad? Ugly? What's your thoughts? Okay. I'm going to subtract this, so I need to change the sign on this. And here's what I'm looking at is negative 13x plus 10x is negative 3x. And then the 5x squared minus the 5x squared is 0, which is the point of what we tried to do, which is a good thing. Are we cool? All right, now I'm going to drop down. And then I'm going to ask myself, what do I need to multiply x by in order to get negative 3x? We just need negative 3. Right, the x is already there, so we just needed the negative 3. All right, now I'm going to multiply this whole thing by negative 3. So I have negative 3x plus 6. Are we cool with that? Okay. I'm going to subtract this, so I'm changing the sign on everything. So now I'm going to, this is 0, and that's 0. Hey, that's a good sign. That's a good thing. Look, this and this were almost identical as far as the steps we took. It wasn't really even that hard, per se. It just was the same exact steps we took. Does that make sense? So what I'm almost saying is, oh, and by the way, I could write this thing right here as 5 times 175 is equal to 875. You can use your calculator and figure that out, right? 5 times 175 equals 875. Well, conversely, I could do the same and just say, okay, well, essentially what you're telling me is x minus 2 times x squared plus 5x minus 3 is equal to x cubed plus 3x squared minus 13x plus 6. If I try it with you, I'm going to erase that part, right? Well, here. Because I know that this times that will give me that. Just like 5 times 175 gives me the middle. We good? I kind of want, the reason why I wanted to introduce this to you today, and then we're going to elaborate this on Wednesday, is because I kind of want your brains thinking in the, I'm going to think inside of the long division, areas. It's not really that bad. This one just takes a lot of practice, a lot of patience, go slowly. All right. I got to end class because I got to start chemistry class now. And those guys are going to be upset at me for starting so late. I'm going to erase this. I'm going to go. I'll talk to you guys later. It was a lot of fun. See you mañana, or see you on Wednesday.